Welcome back to the Deep Dive. Today, we're plunging into a world you might not even know exists. We're talking about the highly specialized control units,
Mm.
the brains, really, behind tiny, high-precision, brushless motors.
hmm
Now, these unseen devices are absolutely crucial. Think everything from cutting-edge surgery,
Mm.
like precisely driving a drill for a dental implant,
Yeah,
all the way to the incredibly tiny gears in maybe your favorite high-end watch.
exactly. It sounds niche, but it's everywhere.
It is. It's a niche but rapidly evolving sector. And these hidden pieces of tech are truly critical to daily life and, well, some of the most advanced work being done right now.
That's right. And for this deep dive, what we've done is extract the most important sort of nuggets of knowledge from our sources. Our goal really is to give you a shortcut, a way to get well informed about this particular market pretty quickly. We'll uncover some genuinely surprising connections and key insights along the way.
Okay, let's unpack this then. So when we look at what's really driving growth,
Mm.
what's pushing this market forward, it seems clear there's this huge rising demand in medical applications,
Mm.
specifically dental and surgical uses.
Mm. Definitely.
And you know why brushless micromotors are so favored here? Well, unlike the older motors, the ones with brushes that wear out and create friction.
Right, the maintenance issue.
Exactly. Brushless ones are like having these tiny, silent, almost perpetual motion machines. They operate nearly silently and give you incredibly precise, really consistent control.
That lack of vibration and noise is key in delicate work.
Absolutely essential for dental practices and, crucially, in minimally invasive surgeries. So as the number of these delicate procedures increases globally,
Yes, they are.
so does the need for these sophisticated control units,
Mhm.
the ones that can finally adjust speed and torque. And that ties directly into, optimal performance and, maybe most importantly, patient safety.
Yeah, and what's truly fascinating here is how that medical need for precision. It isn't just a niche requirement. It's actually a driving force for innovation that kind of spills over into other areas you might not expect.
Ah, okay.
This critical need in medicine, it mirrors the demands you see in precision engineering and manufacturing. Just think about it. Industries like aerospace, electronics, even, as you mentioned, high-end watchmaking, they rely so heavily on micro-drilling, polishing tasks.
Right, tiny, precise movement.
Exactly. And they need highly accurate micromotor control for that. That's where these programmable control units offering real-time feedback become indispensable. Imagine the unit just constantly monitoring everything, the motor's temperature, its exact speed, even how much resistance it's hitting.
Like it's thinking for itself.
Almost, and instantly adjusting, like an expert driver constantly fine-tuning their steering in a critical race. These tools let manufacturers meet really strict quality standards and, frankly, enhance productivity quite significantly.
And here's where, for me, it gets particularly interesting. We're seeing these huge technological advancements, digital control, connectivity.
Mm-hmm.
They're right at the forefront now.
Yeah, the tech integration is accelerating.
Modern control units, they're now equipped with things like touchscreen interfaces, wireless connectivity, Bluetooth, Wi-Fi, and even memory storage for procedural configurations.
So you can save your settings.
Exactly.
Yeah.
And these aren't just, flashy add-ons. They radically improve how people interact with the devices. They streamline the work dramatically. Imagine a dentist being able to quickly switch between preset drilling speeds for different, say, tooth densities with just a tap.
Or an engineer loading routines wireless.
Right. Or an aerospace engineer wirelessly uploading precise polishing routines right from a tablet. These features, they're making these units incredibly appealing to more tech-savvy users. It's a real upgrade to the user experience and operational efficiency.
Absolutely. That digital layer is a huge draw, no question. It feels like the future. But even with all that innovation, we do need to be realistic about some of the roadblocks this market is still navigating.
Okay, challenges.
And the first big one that often comes up is, well, the high cost. Advanced control units, especially with all these complex digital features, enhanced safety mechanisms, they just come at a high price.
It's a significant investment.
It really is. We're talking about an investment that can easily put them out of reach for, say, smaller independent dental clinics, or maybe a single craftsman trying to start a high-precision workshop, especially in emerging economies. It's not just a line item on a budget. It can be a genuine barrier to entry for many.
Yeah, and it's not just the initial purchase price, is it? We're also looking at operational complexity.
Good point.
Think about it. Operating these sophisticated units often requires specialized training. You can't just hand it over. Without adequate knowledge, users risk equipment malfunction or maybe just underperformance.
Which can impact the final quality.
Yep.
Exactly. which can directly affect the overall workflow, compromise the quality of their work, and potentially even impact safety in those critical environments. It's not a tool you just pick up and intuitively master right away.
No, definitely not. And another challenge that's surfacing is compatibility, or lack thereof sometimes. Some newer control units, well, they aren't backward compatible with legacy micromotors or attachments.
Ah, so your old tools might not work with the new brain.
Precisely. It often happens because the new units might use different digital communication protocols, maybe different physical connections that just don't match the older equipment. And this forces users into complete system upgrades, which of course ramps up the costs again
Right.
and potentially slows down market penetration, particularly with places still reliant on older but maybe still perfectly functional equipment.
Okay, so cost, complexity, compatibility, those are hurdles. But looking ahead, there are some incredibly exciting trends really reshaping this market.
Definitely, the innovation isn't stopping. First up, the integration of the Internet of Things, IoT. This feels potentially revolutionizing. Just imagine the possibilities here. Manufacturers are embedding IoT functionalities. Think real-time performance monitoring, remote diagnostics, even predictive maintenance.
So the machine tells you when it needs looking at.
Exactly, before it breaks down.
Yeah.
This means a control unit could literally signal that it needs a service before a failure occurs. Think about minimizing downtime for critical procedures, extending the equipment's lifespan, reducing operational costs. It's a huge win for any facility relying on continuous high-precision operations.
That predictive element is powerful. And alongside that digital leap, another notable trend is the push towards more compact and ergonomic designs.
Making them easier to handle.
Right. Lighter, space-saving control units, often with more intuitive interfaces, they're gaining significant popularity. You see this especially in clinical and industrial settings where, mobility and ease of use are really critical.
Exactly.
These designs help reduce physical strain on operators, especially during long procedures, and they streamline workflows. That's a big deal when you're working with such fine precision for hours on end.
Absolutely. And finally, one more trend.
Yeah.
We're seeing customization and modularity really take center stage.
Tailoring the tool to the task.
Precisely. There's this increasing demand for control units that can be tailored specifically to certain tools and applications. So what this means is you get modular systems, systems with customizable presets, interchangeable components. They offer incredible flexibility and adaptability.
So you don't need a whole new system for every different job.
Exactly. Users can optimize their setups for really diverse tasks without having to replace entire systems. It's like building a precision tool that's perfectly suited to your unique needs. So, okay, what does this all boil down to? We've seen how the control unit for brushless micromotor market is, well, it's evolving fast, really fast. It's driven by those expanding medical and industrial needs we talked about, coupled with some really exciting technological innovation and a strong focus on user-centric design, making them easier, more intuitive to use.
Right, despite the challenges.
Yeah, despite those challenges like high cost and compatibility issues. The innovations we're seeing, IoT integration, ergonomic improvements, that modularity, it really does point to a bright future for these unseen yet utterly essential precision powerhouses.
It really does. And, this raises an important question for you to think about. Considering this big push for customization and modularity, how might future innovations in these control units not just optimize the applications we already have, but actually unlock entirely new possibilities, new kinds of precision work that maybe we can't even imagine yet? What hidden capabilities might they reveal in the tools and the tasks of tomorrow?
It's a truly thought-provoking idea, isn't it? Food for thought.
Yeah.
Well, thank you for diving deep with us today into the incredible, often unseen technologies that shape our world. Until next time, keep exploring.
Imagine for a moment a future where we can actually feed everyone. A growing world, full plates. And at the same time, our planet is thriving, not, struggling under the weight of agriculture. It sounds pretty ambitious, maybe even impossible, doesn't it? But what if I told you there are some really clever solutions already happening, almost hidden, right under our feet? Today, we're doing a deep dive into something crucial, maybe a bit overlooked, controlled release compound fertilizers. CRCFs for short. Think of this as your shortcut. Okay. Your way into understanding a really vital piece of modern farming's puzzle, how to be efficient and sustainable. This is tailored for you, the learner, trying to get the key stuff without getting totally bogged down. Our mission, well, it's to unpack how these advanced fertilizers work, how they boost yields, help the environment, tackle food security, but also, look at the challenges and the cool innovations happening.
Yeah, and that tension you mentioned, feeding people versus protecting the planet, that's exactly the heart of it. Because CRCFs, they aren't just about complex chemicals, not really. It's more about managing nutrients with incredible precision, striking that really tricky balance between getting the most from the land and, well, minimizing the ecological harm. Understanding this stuff helps you connect the dots, see the bigger picture of sustainable agriculture.
Okay, let's unpack that. So our sources point to a few big things driving this CRCF market. First up, this relentless move towards precision agriculture. Farmers everywhere are looking at CRCFs as like a smart tool, delivering nutrients just right, just in time. Think of it like giving your plants a slow-release vitamin pill
Exactly.
instead of just dumping the whole bottle on them at once.
Right. It's about giving the plant what it needs when it needs it, sometimes down to the square foot or even, plant by plant. And if you zoom out, that precision, it isn't just neat, it directly boosts crop yields a lot, while also dramatically cutting down nutrient loss.
Loss how?
Well, things like leaching, where nutrients just wash away in the water before the plant gets them.
Ah,
Or volatilization, where they basically evaporate into the air.
right.
This is huge for high-value crops, things that need really exact nutrient levels to thrive. Makes every bit count.
So we're stopping fertilizer from just like washing down the drain or floating off?
Pretty much, yeah.
Sounds simple, but the scale of waste without these must be enormous.
It can be significant.
And it's not only about yield. The sources say environmental rules are a massive driver, too.
Definitely.
Governments are getting tougher on agricultural runoff, greenhouse gases, which kind of forces the industry to find fertilizers that plants actually use efficiently, minimizing that environmental hit.
It's a powerful push.
It seems like a win-win, right? Better productivity, better for the planet.
That regulation point is absolutely key.
Yeah.
It makes us face that core question. How do we feed billions more people without wrecking the planet? Global population keeps rising. Good farmland is getting scarcer. So food security, higher crop yields, they become critical. CRCFs offer a solid way to keep soil fertile and meet that food demand, but with fewer fertilizer applications overall.
Doing more with less.
Exactly, which is fundamental for any kind of real sustainability.
Okay, so on paper, CRCFs sound amazing, like a perfect solution.
They have huge potential.
But like any big tech shift, there are always hurdles, right? Things we need to figure out.
Always.
And the first big one the sources flag is cost. Simple as that.
Uh-huh.
CRCFs are just way more expensive. Those coatings, the complex formulas, they add up.
They do.
And it's not just a budget line item, it's systemic. We've got tech that's so advanced it almost prices out the farmers in, say, developing regions, the very people who could gain the most from the efficiency. It's a tough paradox.
That economic barrier is definitely a major one, because even though the long-term payoffs are clear,
Like less labor, fewer times you have to apply it.
right, fewer applications, better environmental results, that initial investment, it can really put the brakes on adoption, especially in places needing those benefits most, maybe for climate resilience or just basic food production.
Right, the sticker shock is real. But even if they were cheap, there's another barrier, maybe less obvious, just knowing about them, and crucially, how to actually use them properly.
Ah, the knowledge gap. Yes.
Sources mention big problems with limited awareness, not enough support services, especially in developing markets.
That's very true.
If farmers don't get how they work or can't get good advice, well, uptake is going to be slow.
Naturally.
That knowledge gap really holds back market growth, particularly where boosting farm output is super urgent.
And beyond just awareness, there's a tricky technical bit too.
Yeah.
Getting the nutrient release rates to perfectly match what different crops need. Soil types are incredibly varied. Climates change. It makes optimizing those release profiles really quite difficult.
So not a one-size-fits-all kind of deal.
Definitely not. And that can lead to inefficiencies sometimes, if it's not managed right. It requires a certain level of expertise on the ground, which isn't always easy to find.
Okay, so we have the hurdles, but where's the innovation? Where are the breakthroughs happening? Because despite all that, things are moving fast in this market.
Oh, absolutely.
We're seeing loads of research into things like biodegradable coatings, nano coatings.
Yeah, that's exciting stuff.
Imagine a coating so thin, like atom-level thin, allowing super precise, almost on-demand nutrient release.
And leaving virtually no residue behind.
Wow.
And these advances, they fit perfectly with those tougher regulations we talked about and just the general push for sustainability. It's like building a better mousetrap, one that's greener, smarter, it meets the farmer's needs and the planet's long-term needs. It's a really dynamic area right now.
And it gets even more interesting. Integrating CRCFs with smart farming tech. That's really picking up steam.
The digital agriculture angle.
Yeah. Imagine combining these fertilizers with, say, intelligent irrigation systems, sensors monitoring nutrients in real time.
So farmers can use data to guide fertilization, really fine-tuning it for specific crops.
Exactly. That fusion, the sources suggest, that's really the future.
Which leads to kind of an interesting situation right now. Where are we seeing this advanced stuff taking hold first?
Where is it?
Well, we see faster adoption of CRCFs in horticulture and specialty crops.
Like fruits, vegetables,
Yeah.
flowers.
Exactly. Fruits, veggies, ornamentals. These tend to be higher value crops, where hitting consistent quality and yield targets is absolutely critical. So the higher cost of CRCFs makes more economic sense there, maybe compared to, say, large-scale staple crops like wheat or corn, initially at least.
So it's like a testing ground, proving the tech before it goes wider.
You could see it that way, yeah. It builds the case. So looking back at this whole deep dive, CRCFs really have this dual nature, don't they? They're a powerful solution, but also a complex challenge.
Definitely both.
They represent a really significant step towards agriculture that's sustainable and high yield. Minimizing waste, reducing environmental impact, that's vital for the planet. But we just can't gloss over the hurdles. Cost is real. Technical complexity is real. What's crystal clear, though, is how dynamic this market is. It's being pulled by global food demand and pushed by constant innovation in how we actually grow that food.
And talking about innovation, that future outlook, it is exciting. We mentioned those biodegradable and nano coatings better for the environment, even more precise nutrient delivery, almost surgical. But it's that integration piece, smart farming, intelligent irrigation, sensors, that really feels like the next chapter, moving towards genuinely data-driven fertilization, especially, as you said, for those high-value crops where every nutrient really has to count.
Which brings me to a final thought, maybe something for you listening to mull over.
Yeah.
Given this huge potential CRCFs have, potentially revolutionizing food production, what role do you think policymakers and even consumers have in helping overcome those adoption barriers, particularly for, say, small-scale farmers in developing regions? How do we make sure this innovation actually reaches the people who need it most? How do we balance the economics with the environmental needs? It's a big question.
Lots to think about there. Thank you for joining us on this deep dive today. We really hope this look into controlled release compound fertilizers gave you some fresh perspective on how tech, farming, and sustainability are all coming together. Keep exploring.